now we're going to do dimensional analysis for reactant O2. So I'm going to do the same process. We always start with what we're given. So in stoichiometry, start with what you're given, 92 grams of O2. And I simply got this number from the problem. They gave me 92 grams. Now, next step, step 1, convert to moles. Since this is O2 this time, we want to convert to moles of O2. We're going to use the molar mass of O2, which is 32 grams, because we know 1 mole of O2 weighs 32 grams. So that's step 1. Now step 2 says molar ratio. So I'm going to look, I have here 2 moles of H2O are produced from how many moles of oxygen? Just 1 mole of oxygen. And then I want to convert to grams of H2O. That's the third step. So step 3, convert to grams. I know 1 mole of H2O weighs 18.02 grams of H2O. So let's go back. I have grams of H2O here. I can cancel it out with grams of H2O here. Moles of O2 cancel out with moles of O2 in the denominator here. And moles of H2O cancel out. So all I'm left with is grams of H2O, which is what I want. I'm looking for how much product can be produced. So when I multiply all the numbers on the top and divide it by all the numbers in the denominator, I get an answer of 103.6 grams. So I'm going to write that up here. O2 produces 103.6 grams. So what you want to do, so the last step we want to do to find the limiter. So to find limiter, you want to compare H2O produced. Now if we look back up here, O2, if you look in your map, O2 is able to produce. So 92 grams of O2 produces 103.6 grams of H2O. And H2, so 42 grams of H2 produces 375 grams of H2O. So which one is your limiter? The one that produces less grams of H2O, which would be O2. So the answer is O2. Oxygen gas is your limiter. So now you want to skip to number 19. So in your chemistry final study guide, let us start number 19 together. So this is a solutions problem where we dealt with molarity. And that's what your problem is asking for. So with molarity, big M, that means molarity. Molarity equals moles of your solute over your volume, which is liters of your solution. So the problem gives you 2.00 moles of lithium bromide. And it's dissolved in a volume of 500 milliliters. So the volume equals 500 milliliters of water. So we already know what our moles of solute is. That's 2 moles. So up here I'm going to write equal to 2.00 moles. But our volume here is in milliliters, and we know we need liters, so we want to change this to liters of solution. All you need to do, you can set up a proportion, or you could just move your decimal place over. But let's set up a proportion. I want to know how many X liters I have in 500 milliliters. So I make that equal to 1 liter over 1, 2, 3, 1,000 milliliters because I know there are 1,000 milliliters in 1 liter. I'm going to cross multiply. So I get 1,000x equal to 500. You simply divide both sides by 1,000, so you get 500 divided by 1,000, which equals 0.500 liters. So 500 milliliters equals 0.500 liters. So I'm simply going to put that up in my equation, 0.500 liters, and I get an answer of 4 moles over liter, or simply you can say 4 molar. And that is your answer for number 19. 4 molar is the molarity of the solution. So problem number 20, let's skip down to problem number 20. This has to do with solutions as well, but it has to deal with dilutions. It says how many milliliters, so I'm looking for how many milliliters of the lithium bromide solution from problem number 19 would you need to make a 300 milliliter solution of 1.0 molar. So the molarity from problem number 14, we just calculated it to be 4.0 molar. So let's look at this. Let's say we made a solution. So we make this solution, and this solution is 4.0 molar. Now, what they're asking from you is, how would you make this 300 milliliter solution of a 1 molar solution? So I want to make (300 milliliters of 1.0 molar. So how would I make this? I want to know how much of this I would need to make 300 milliliters of a 1 molar solution. Now remember, this first 4 molar solution, think of it as your stock solution. So I want to know how many mils of this I need to take out. I want to know how many milliliters I need to take out of this to put into here. Alright, so the equation you need to use is M1 V1 equals M2 V2. M1 is your first molarity from your stock solution, so that would be 4.0 molar. And we're looking for that first volume, so we can simply write V1 equal to M2, that's the molarity we're making, which is 1.0 molar, times the total volume that we want to have, which is 300 milliliters. So you simply divide both sides by 4.0, and you get V1 equals, and you get V1 equal to 75 milliliters. So what this problem is saying is I need 75 milliliters of a 4.0 molar solution to make 1.0 molar and 300 milliliters of that 1.0 molar solution. So your answer is 75 milliliters.